Here we go. We have a question, solve the Sudoku. So we have given an incomplete Sudoku configuration in terms of 9 cross 9, and our task is to solve the Sudoku. It is granted that the input Sudoku will have exactly one solution. A Sudoku solution must satisfy these three rules. Each of the digit between 1 to 9 must occur exactly once in each row, in each column, and in each 3 cross 3 sub-box. Zeros represent blank that needs to be filled with the value between 1 to 9, while non-zero cells are fixed and we cannot change that value. So we have given this matrix, this is the matrix, and this is the modified matrix. This is another matrix, this is the modified matrix, and we don't need to return the array, we just need to update the input data. So now let's build the approach. So I have taken the example here. So this is the input matrix. I have represented like this, where black represent a value that needs to be filled. So whenever we encounter a value, okay, so whenever we encounter a value, so we will check either it is 0 or non-zero. If the value is non-zero, we will jump to the next value. So this value is already filled. We will jump to the next cell. This is the cell. This cell value is 0. So you can check the cell value is 0. So we need to fill some value. First, we will try to put 1. Is 1 possible? So we need to check, is 1 there in same row? No, 1 is not there. So this is valid. Is 1 present in same column? No, it is not. Is 1 present in same box? No, it is not. So we can place 1. If it is present, we will try to put the next value. So next we will jump to the next cell. It is already filled. We will jump to next cell, already filled. Jump to next cell, already filled, already filled, already filled. Then here I think this is not 4 cross 4, this is 4 and 0. Yes, 4 and 0. And everything else is, I think, correct. Let me verify it once again. Yeah, everything else seems fine. So we are on to this cell. Can we place 1 here? No, we cannot place. 1 is already there. Can we place 2 here? 2 is not there in the same row. Is 2 there in the same column? No, it is not. Is 2 there in a sub box? No, it is not. Then we jump to the next cell. We can place 2 here. 2 is a safe value for this position. Then we jump to the next value. So we are on to this cell. Can we place 1? No, 1 cannot be placed. Then can we place 2? No, we cannot place. Can we place 3? No, we cannot. Can we place 4? 4 we cannot. 5 we cannot. 6 we cannot place 6. 7 not. 8 also not. 9 is 9 possible? 9 is not present in the same row. 9 is not present in the same column. 9 is also not present in the same box. Then we jump to the next cell. Now my j reaches 9. If my j reaches 9, I will reset my j and jump to the next row. I will jump to the next row. So we have a condition here. If my j reaches 9, we will jump to the next cell. So next cell is this. So what I will do, I will reinitialize my j and increment my I. Initially I and j is 0. Next we are on to this cell. This cell is already filled. Already filled. Can we place 1 here? No. 1 is already there in the same box. Can we place 2? No. We cannot place 3 also. Can we place 4? 4. 4 is not there in the same row, 4 is not there in the same column, 4 is not there in the same box. Next we jump to the next cell. Can we place 1? Yes, we can. In the same box it is also not there. Next we jump to the next cell. Can we place 1? 1 we cannot place, 1 is already filled. 2 is already filled. 3, can we place 3? 3 is not there, 3 is not there, and 3 is not there. 3 is a safe position for this value. Next, 1 is not possible, 2 is not possible, 3 is not possible, 4 is not possible, 5 is not possible. Then 6 possible. 6 is not possible for 6 is not possible for 6 is possible for the current row. For the current column, no, 6 is also not possible. 7 is already there. 8 is already there. Can we place 9? In the same row it is not there, in the same column it is also not there, in the same box it is also not there. Yes, 9 is a safe position. Can we place 1 here? No, we cannot place 2, we cannot place 3, we cannot place 4. Then 5, for 5, is it a safe position? No, 5 is also not possible, 6 is also not possible. 7 is not there in the same row, 7 is not there in the same column, 7 is also not there in the same box. 7 is a safe position, 7 is a safe value. Can we place 1? No. 2 is not possible, 3 is not possible, 4 is not possible, 5 is not possible. Can we place 6? 6 is not there, 6 is not there, 6 is not there. So 6 is a possible value. Then we jump to the next index. 1 is not possible, 2 is not possible, 3, 4 is not possible, 5 is not possible, 6 is not possible, 7 is not possible. Then 8 is also not is it possible? Let me check. So 8 is not there, 8 is not there, and 8 is not there either. So 8 is a safe value for this position. Next we are on to this cell. 1 is not possible, 2 not, 3 not, 4 not, 4 is there in box, 5 is not, 6 is not, 7 is not, 8 is not, 9 is also not possible. So if I fill the value in this sequence, we cannot fulfill our this our criteria to make to solve the Sudoku. We cannot fulfill the criteria if we fill value in this manner. So we need to do backtracking. So for this value, we have already filled some value. So this path is not possible. So we need to backtrack. First reset this data. It is 0. Then this value is not there. So first we will backtrack. We cannot place 3. If I place 3, we cannot solve our Sudoku. Can we place 9? 9 is not possible. So this value is backtrack. So we will backtrack from this point, and we have filled 6. Can we place 7? Let's check. Can we follow this path? 7 is not possible. Can we place 8? 8 is not there, 8 is there, so we cannot place 8 either. Can we place 9? No, 9 is there in the box, so we need to do backtracking. We will place 0 and go to the previous cell. Recursion will do this. So we have placed 7 before. Yes, 7. So now we will place 8. Is 8 possible? Let's verify it. 8 is not there, 8 is not there, and 8 is not there. Yes, we can follow this path till now it is valid. So we'll jump to the next step. 1 is not possible, 2 is not possible, 3, 4 not possible, 5 is not possible, it is there in the same row. 6 is not, 6 is possible, 6 is not there in the same row, 6 is not there in the same column and in the same box. So 6 is one path. we are on to the next cell. So we can place 1 is not possible, 2 not, 3 not, 4 not, 5 is also not, 6 is also not, 7 is possible, 1 7 is possible, yes, it is not there, it is not there, it is not there. 7 is possible. Then we are on to the next index. 1 not, 2 not, 3 not, 4 not, 5 not, 6 not, 7 not, 8 not, 9 is also not. So this path is also not valid. Can we place 8 here? No. We cannot. We can place 9 here? No. So we will again do backtracking. Can we place 7 here? No. 8 is also not, 9 is also not. So this index is also not. Can we place 9 here? No, we cannot. So we will do backtracking. It is 9. So we will again do backtracking. Can we place 4 here? No. 5? No. Because same box. 6? No. 7? No. 8? No. 9? No. Can we place 2 here? No. Can we place 3 here? 3. Yes, we can place 3. So using this approach, we will try to fill the matrix. I hope you got the idea. So first, this is our thing. If j reaches 9, I will do I++. What if I reaches this index and I will jump to the next index? My j reaches 9 and I will again reset, and my I reaches n. My I reaches 9. If my I reaches 9, it means we have filled every single cell, and this path, this is solved, is this Sudoku is solved. So we will return true. This path is valid. So that's how this will work. Let's code this. So we have solved passing I and j. This is the base case. This is another base case. If the value is non-zero, means the value is already filled, we will jump to the next cell. If the value is not already filled, we will try to fill the value from 1 to 9. Can we place the value x on I or j position? So we have a separate function named valid. So valid will check, is value x there in same row or same column or same sub box. If it is there, it will return false, means the value x is not valid. If the value is not there, we can fill it. This is a valid index, this is a valid x. So we will put it and jump to the next cell. So the main thing is valid. So how do we check valid? If it is a valid, so first we will check in the same row. It is there in the same row. So we are changing column, and our row is the ith row. Our ith row, we are checking for the same row. So let's suppose I have this data and I am putting 5. So I have to check in the same row. How do we check? I am changing my j. My I is fixed. My I is fixed. So my I fixed. I am changing just my column. If the value is there that I want to place, if the value is already there, then it will return false. The value x for this I and j index is not valid. Is value there in the same column? So let's check. Is value there in the same column? So in this, my I is changing, my j is fixed. My I is changing, my j is fixed. If it is there in the same column, means we cannot place, the value is false. This is a not valid value. Then for the same box, this is interesting. We want to find in the same box. So let's suppose this is my index, and I will start from this. Or let's suppose I got this value. I am here, and I want to find whether 4 is a valid value for this box. So I will iterate like this, and this. So this is my starting position, starting I and starting j. How do we find my starting I, my starting j? So let's talk about this index. What is this? This is 0, 1, 2, 3, 4. 4 and 6. So first of all, find your box number. So in each box we have 3 cells. In each column we have also 3 cells. So 3 and 3. So if we got 1 and 1. So this is 1 and 1 box. This is 0 0 box. This is 0 1 box. This is 0 2 box. This is 1 0 box. This is 1 1 box. This is 1 2 box. So I got my box, and in each sub box we have 3 elements. So I will just multiply 1. I will just multiply with 3. Just multiply with 3. Then I will go to my starting point. This is 3 3. This is 3 3. Let's find for this. This is my starting point. So what will be the value? Let me first erase this. So what is this index? 0 1 2 3 4 5 6 7. So 7 and 0 1 2 3 4 5 7 5. This is 7 5. So 7 by 3 we got 2. 5 by 3 we got 1. So this is my 2 1 box. So if I multiply with 3, because in each cell, in each sub box we have 3 elements, so we got 6 3. This is 6 3. You can check it. 0 1 2 3 4 5 6. 6th row. 0 1 2 3 third column. So we need to just divide by 3 and multiply by 3. So if we got I and j, we need to find its starting point. This is my starting point for these sub boxes. This is my starting point for these sub boxes. So first of all, divide by 3, because in each cell we have 3 boxes, and multiply it by 3. Now you may argue that these 3 will cancel out these 3, but it will not. First bracket thing will execute. So let's suppose we got 7. So 7 by 3, first it will give me 2. So then 2 multiply 3, we got 6. So that's how it will work. So first bracket thing will execute, and it will try to find the box number. So it will consider it like this box. So this is the starting point, and for the 9 cross 9 matrix we just need to multiply with 3. So this is the formula. So first I am dividing it to find the starting point and starting j. Then in each sub boxes we have 9 cells. We have 3 rows and 3 columns. So number of rows we have only 3, number of columns we have only 3. Then for the matrix, starting multiply 3, starting multiply 3, that I have just shown you. So starting, so I have named it starting I, and I have named it starting j. So starting I multiply 3, starting j multiply 3, plus row for iteration, plus column for iteration. If the value is there in the same box, just return false. If value is not there and we can place it, just return true. The value is true. If we got value as true, we will put the value and try to solve for the unsolved Sudoku. We will jump to the next index. And if by placing x we can solve the Sudoku, the recursive function will return me true, and I will just return true by placing x. If x is not a valid value, we need to do backtracking. So just reset the data. I've just reset the data, and if this thing will not, if the Sudoku is not valid, but in this case it is mentioned that we can place it, so it will work. But like we have shown, we have seen it here. We have gone to this path, then we have reached this, then we are trying to find 1 2 3 4 5 6 7 8 9, and nothing will work. So we will return false from this path. We cannot place. So if at any point this thing will this thing will hit, we need to do false. So if we cannot place any value from 1 to 9, we will return false. And at the end we have at the end we solve our Sudoku and return true. So this code will work. Let's submit it, and let's try to find the time complexity. For each and every path we are placing 9 values. We are placing 9 values. In the worst case, let's suppose we got an empty Sudoku, no values there. So from each point we are we are trying to put the value between 1 to 9, and we are placing value 1 to 9. So we have 9 paths, so it will be 9 raised to power n cross n. I think this is the correct time complexity. Yeah, 9 raised to power 9 raised to power n cross n. And space complexity is order of n, we can say, but I doubt it is not order of n. On the worst case, we will go to n cross n, because we are solving it using recursive. We are solving it using recursion, and it will store, the recursive stack will store n cross n items. So the space complexity is, I think, n cross n. So that's it. Thank you all for watching this video.